So in this lesson, we're going to learn about topic 2.5 and 2.6. They go very well together. We're going to be applying the power rule, and we're going to learn derivative rules that are the constant, the sum, the difference, and the constant multiple. So our essential question is how to use basic derivative rules. And your I can statements are I can use the power rule to take a derivative, and I can use the derivative of a constant. I can take the derivative of a constant, sum, difference, and constant multiple. So the past few lessons, we've been taking derivatives with the limiting process. However, we can actually do them another way. There's a shortcut method. So we're going to learn the shortcut method today. But before that, we're going to get into the notation. There's a bunch of different ways that you can write the notation for derivatives. So one of them is f prime of x. We've seen that one. We can also say y prime of x. And then we can say one that is the derivative of y with respect to x. So that one means derivative of y with respect to x. And then there's one more that's more common that we see is they'll sometimes do this ddx, and then they'll put the function on the inside, and that's a symbol that means take the derivative of the function on the inside. So you're going to see all of those. They're all interchangeable. The reason that there's so many, there's also a few more, is because when calculus was being invented, at least two different mathematicians were working on it at the same time, and they all had a different notation that meant the same thing. So we're going to look at our constant rule first. So the derivative of any number is just 0. Basically, you're thinking about that. What's the slope of a horizontal line? The slope of a horizontal line is 0 because the line y equals 5. If I drew that, right, the slope would be equal to 0. So the derivative of a constant is 0. A special case of the power rule is the derivative of x is just 1. Let's look at the actual power rule, though. So what it's saying is the power rule says, and notice here's that derivative of the function notation. What I do is I take whatever the power is and I move it to the front, and then I subtract 1 off the exponent. That doesn't seem so hard. So let's say I just had x squared. I'm going to take the x squared to the front, or the 2 to the front, and then I'm going to subtract 1 off the exponent. I get 1. So the derivative of x squared is 2x. If I went back to this one here, the derivative of x to the first, I take the 1, put it out front, and then I subtract 1 from the exponent. I get x to the 0, which is just 1. So let's go ahead and make it a little bit more complicated. Find the derivative of each of the following. So the derivative of f of x equals x to the 5th. I'm going to take the 5 and bring it in front. I'm going to write my derivative notation, f prime of x. So bring 5 to the front, subtract 1 off the exponent, I get 4. Okay. Now, one of the rules for derivatives is you have to have an exponent, and you have to have the exponent on the numerator level in order to do the derivative. So this one here, I'm going to convert it into an exponent first. Remember, when you have a root like that, the roots are at the bottom of a tree, so you always put the root at the bottom. And then I'm going to go ahead and move this to the front to take the derivative. I'm going to use the g prime notation, equals 3/4 x, and then I'm going to subtract 1, but 1 is going to look fancy this time. It's going to look 4/4. So 3/4 minus 4/4 is negative 1/4. That is a perfectly good answer, but that might not be what it looks like in a multiple choice question. They might take this and bring it back downstairs. So it might look like 4x to the 1/4. They could also convert it back into a 4th root. So it also might look like that. Okay, before I can do the derivative of this one, I need to bring it upstairs. Remember, to bring it upstairs, I make the exponent negative. And I'm going to go ahead and take the derivative. We're going to bring our exponent to the front. I get negative 3x. I'm going to subtract 1. That gives me negative 4. That is a perfectly good answer. However, that might not be what you're given in one of the homework systems or multiple choice. So I may need to bring this negative exponent back downstairs. When I bring it back downstairs, it becomes positive x. I'm just going to use y prime notation. This is a constant. The derivative of any constant, no matter what it is always 0.